guess we're recording now. I want to say 2 words about, well, for one thing, if you've been following this course up to now, seen some of the other recordings, you might feel like something's a little bit missing because I might refer to some formula and you're like, what formula? Where do I find that formula? And it's going to get worse with subsequent material. You should have some formulas at the ready when you do a lot of these problems. You don't want to go searching through a textbook. Oh, this was on page 247. This was on page 603. So what I did when I taught this course, I would give a comprehensive final exam, and I provided formula sheets. I considered those formula sheets everything you really needed to get through an exam or even homework. So you really wouldn't need a textbook. Even if it were an open book exam, you don't want the time spent searching through a textbook. So let me show you that formula sheet. It's 4 pages. Just use this cursor. Hopefully you can see the cursor. 4 pages, and I'll just go through quickly what each thing is. First is super basic math, including the quadratic formula. A couple of key things about trig functions, especially when there's 0, like sine is 0 when the argument is integer number of pi, etc. We've talked about these in other recordings, what basic e to the I things are. And we use hyperbolic trig a fair amount in this course. A lot of people aren't that familiar with it. Here's their graphs. Let's see, this green even function is the cosh, or hyperbolic cosine. This odd function in red is the sinh, or the hyperbolic sine. This dashed line is the hyperbolic tangent. Some key facts about them, especially how to take their derivatives, which are kind of neat. Derivative of cosh is sinh, and derivative of sinh is cosh. It's that simple. We've gone through this before. Odd and even functions. Add 2 evens, the result is even. If you add 2 odds, the result is odd. Multiply evens and evens, or odds and odds, the result is even. If you multiply an even and an odd, the result is odd. And that helps you take integrals. Here's some key even and odd functions that before. By the way, if you want this sheet, you can either look at this video again or email me and I'll give you a PDF, assuming I don't get a million requests or something like that. Back when we did series solutions at the beginning of this course in Math B, Engineering Math B, here was some key formulas for doing series solutions. Standard form, the initial roots formulas, and what the power and Frobenius series are in their first 2. Key formulas for orthogonal expansion, inner product. This overhead bar means complex conjugate. You'll rarely use that. You'll usually be working with real functions, in which case you can ignore this bar, whatever the function is. It's just a refresher. I'm not going to explain every single formula because we've gone through most of them by now. Here's the exponential Fourier series. Here's the table of the trigonometric Fourier series. A lot of times when we're doing the partial differential equations, we're matching coefficients, or we're matching coefficients of one of these trigonometric series, Fourier series. I wouldn't expect you to memorize these things. Keep them on a sheet, and here it is all in one table. So you might, you really like to have this in your left hand or somewhere on your desk or something when you do partial differential equation problems. This P-Sturm-Liouville. Well, here's the equation. Here's another form of it, and how to get from the second form to the self-adjoint form so you can find the weighting function. And when you have the weighting function, you can do the orthogonality relationship, which helps you do an orthogonal expansion. Here's where we're not going to do a full review of differential equation course. Here's a bunch of differential equations that are going to crop up in this course. We'll use them mostly to solve partial differential equations, but we don't want to re-solve these equations. So here they are and their general solutions. This last one is the Legendre equation, and we only list Legendre polynomials, which are particular solutions, because when we use them for partial differential equations, we'll always reject other solution to the Legendre equation because it will violate some kind of boundary condition or condition imposed on the solution. The second to last two equations are Bessel equations of the first kind, Bessel equations and modified Bessel equations. They're general solutions for, I guess, of order 0. That's all we're really going to find or deal with when we use these to solve partial differential equations. Here's what they all look like, so you know where they are not bounded and which ones cross the 0 axis an infinite number of times. Here's the Fourier-Bessel. Well, these two are the Fourier-Bessel series, really. And they depend on your eigenvalue generating relationship. So if this is your eigenvalue generating relationship, you use this expansion. We haven't got to this yet, but we will. And if this is your eigenvalue generating relationship, this is your Fourier-Bessel series in that case. Here's a special Fourier-Legendre orthogonal expansion. We haven't got to these yet in the course. These here, we're going to get to them shortly. Anyway, here it is all in one place. And this last list of formulas comes at the end of the course, where we use Fourier transform to solve partial differential equations. So we'll get to these formulas later, but for now, here they all are on just 4 sheets. You can look at this again, freeze it in the recording, or you can email me and ask for a PDF. Anyway, hopefully you're not, you don't have to spend a lot of time looking for all the formulas I talk about when I go through these. Anyway, let's get on to the next subject in another recording.